Nomenclature, nomenclature, nomenclature. That's what this lecture video is about. I know, you thought you got away from nomenclature back in Orgo 1, but guess what? It's sneaking back around the corner and it's creeping up on you. So can you remember the basic rules of IUPAC nomenclature? Because if you can't, you're in a world of hurt with this lecture video. No, it's actually not that bad. You're going to see that this is no more difficult than any of those other examples that we did back in Orgo 1 together. So let's talk about the nomenclature of benzene. Okay, so here is the benzene molecule. It's what we've been focused on, folks, forever, it seems like. We're already, and we're only a couple of lecture videos into this material. So this is what we call benzene. Well, someone's going to come around and say, well, now, if we take this structure and if we really IUPAC it, this is a ring structure. So shouldn't we really be calling this a cyclohexene ring? And I'm going to say, well, yeah, you could. And then you're going to look at this and say, well, now I called it cyclohexene, but there's more than one double bond. And we learned back when we talked about alkenes that I should really bring a prefix into that, right? And I'm going to say, yeah, that's right as well. So I'm going to come through and change and modify this ending. It is an ene, but there's 3 double bonds here. So this is a triene. So cyclohexa triene. We just don't want to bump the X up against the T. That would look silly, right? I mean, how would you say that? CYCLOX or HEXTRI? No, that's silly. How would we do it? So we add that little A in there just to give you a nice little vowel vanillite, and that way we can say cyclohexatriene. But where are those double bonds located? I'm going to have to number the ring and tell you where they're going to be. Okay, so let's number this one as spot 1, and we'll just go around the ring. There's 2, and there's 3, and there's 4, and there's 5, and there's 6. So you're going to say at spot number 1, there's a double bond. And then at spot number 3 is my next double bond. And then at spot number 5, there would be my next double bond. So 1, 3, 5, cyclohexatriene. Now, that's how you would have named it back in the day. Before we even talked about benzene, you would have used the alkene nomenclature, and that is exactly how you would name it. Is that an acceptable name? And the answer is, yeah, we can call it that if we want. But this group is such a common group in organic that we just forget about IUPAC because that is long. I'm too lazy to write down that name every single time that I need to bring it into the picture. So we've got to do something a little bit more simplistic as far as the nomenclature system is concerned with benzene. And that's where the common name of benzene comes from. So what that basically means is that anytime I see this group, there's a very good chance that I'm going to refer to this group as a benzene group. I'm not going to name it as 1,3,5 cyclohexatriene. For goodness sakes, would be here forever if we had to include those into the nomenclature of these systems. All right, so what does that mean to me? What does that mean to you? Well, look at this nice little trick. I'm going to come in and I'm going to draw this benzene. I'm going to put a circle there because that's what that double, single, double cause you trouble means, all the way around, delocalized. And let's slap a bromine on this. Okay, well, how would I name this? Let me show you how easy. What does BR stand for? Bromo. That's what we've always treated it as. In all the other nomenclature system that we've had, we've called BR bromo. And then, what's the name of that ring? Benzene. Bromobenzene. There you go. There's the name, the accepted name of that structure. Let's do another. Was that easy? I hope you like that because this one's no more complicated. How would you name this? Well, that's Cl. Chloro. Good job. And what's the ring structure called? Benzene Chlorobenzene. There's the IUPAC name for that particular molecule. Now, doesn't that look much better than 1-bromo 1,3,5-cyclohexatriene. I think it does, right? And that's one of the reasons that we do this. We get away from the proper IUPAC name this time, and we do regard benzene as a proper IUPAC almost in a way for that particular structure and dynamic. And anytime we use the word benzene, we know exactly what we're referring to. It's very similar to water, right? We're going to call this water no matter what we do. We do not call this dihydrogen monoxide. We could. I mean, we're not in violation of any type of nomenclature rule. We just don't do it, though, because water is so common, and we know what water is. And anytime you say water to someone, they know exactly what molecule you're referring to. Benzene is just as common. So that's why we call this benzene. We know what that means. We know the structure for it. And, folks, that's really all that we've got to do here. All right, so let's take a look at another. Let's take a group like this and add NO2. How would you name this? All right, well, if you go back and take a look at maybe some charts, you'll see what we call the NO2 group. The NO2 group is going to be referred to as nitro. Okay, well, that nitro group is attached to a benzene. So this is going to be called nitrobenzene. That's it. That's all you got to do. Simple as that. So you're probably scratching your head and you're probably wondering, okay, there's got to be more to this. I mean, this is just way too easy. So when is he going to throw me the curveball? All right, so let's take a look here at this structure. How would you name it? Well, you would look at this group and you would say 2-carbon chain. Well, I learned that in Orgo 1. A 2-carbon chain is called an ethyl. Okay, well, good job. It is. It's their ethyl group, and that ethyl is attached to a benzene. So ethyl benzene is going to be the IUPAC name for that molecule. Well, I didn't throw you a curveball there either, did I? No, I didn't. And I'm actually not going to throw you a curveball other than these structures that you're going to have to memorize. Because just like benzene, that is more or less a common name for that particular molecule. There are common benzene-containing molecules, which means it's a larger molecule than just the benzene structure, and they have common names that they're associated with. All right, so for instance, let's do this with a CH3 group. All right, so if I have that ring with a CH3 group, I could, based on what we've done so far, what is the name of this CH3 group? Okay, this is called methyl, and then that's on a benzene, so I can call this methylbenzene. Okay, and I'd give you credit. However, this structure is so common. It shows up all the time that methylbenzene is somewhat annoying because it is more wordy. There's more letters that we have to write down. So there's a common name that comes along with that grouping, and that common name is called toluene. 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 Okay, the reason that I mention that is in a laboratory environment, we often refer to that compound as toluene all the time. And toluene doesn't give you really an idea of how that structure is made. But now you know that toluene is the common name for a benzene with a methyl group. So if this piece is part of a larger chain, and we have to name that piece, well, we can't really name it methylbenzene easy sometimes. But we can name the word toluene, and that will take care of quite a bit of it. So these will come important much later on down the road. Right now, we just need to introduce a couple of common benzene-containing groups and give you common names for those and get you familiar with them. And that's the point of this lecture. All right, so there's toluene. There's our first one. Memorize it. It's important. It's one of the few times that I say memorize in the class. Next one is this benzene group with an OH. I could name this as an alcohol. I'm not going to, though. There's a common name that this goes by. Anytime I see this, I'm going to use the word phenol in order to name it. Another common name associated with that benzene-containing group. So benzene with an OH is phenol. Another one. Here's my ring, and off of this ring is an NH2. Again, it's an amine. That amine group is on a benzene ring. We have a common name that we use whenever we see this in organic, and this is called aniline. A-N-I-L-I-N-E, aniline. Next is a benzene ring, and off of this is an SO3H. This was a little weird. The reason is because the name is much longer than what it should be. So this structure is going to be called benzene sulfonic acid. Again, a common name that we use whenever we see that grouping together. Another one is a benzene with an OCH3. Now, this OCH3 group is called a methoxy. That's what we learned in Chemistry 251. That's a methoxy group. So this methoxy attached to a benzene has a common name, and we call this anisole. A-N-I-S-O-L-E. Anisole. Next, we have a benzene, and then we have a CH double bond CH2. Folks, this is a vinyl group. And again, we were introduced to vinyl back in the alkene lecture of Chemistry 251. And that vinyl group is attached to a benzene ring that has a common name. And that is called styrene. Next, we have a benzene. And off of this is a carbon, double bond O, OH. Well, you look at this compound, that C double bond OOH is something that we talked about in Chem 251. This is a carboxylic acid group. So this carboxylic acid group is attached to a benzene ring, and this is called BENZOIC, benzoic acid, for the carboxylic acid. Next, benzene ring, and this is a C double bond O with an H. Well, we're learning that this C double bond OH, that is an aldehyde group. All right, so that aldehyde is attached to a benzene, and we call this benzaldehyde. Again, two morphed together, there's your name. And then we've got one more, and this is a benzene ring with a carbon, triple bond, nitrogen. That C triple bond N is called a nitrile. So the nitrile group is on the benzene ring, and we call this benzo nitrile. All right, folks, so there you go. There's the grouping of what we call common names, and these common names you have to learn. These common names you have to memorize, because these are going to start creeping up in our reactions. They're going to start creeping up in more complicated nomenclature when we get to that point, and we're going to have to be able to handle them this way. So that means in the future, whenever I see a benzene with an NH2 group, I'm not going to have to struggle with how to name that component when I see those two pieces together, because automatically my mind should think, oh, there's aniline. I know how to name that. Whenever I see a group that looks like this down below, I can't go through and think about, oh gosh, that's a carboxylic acid. How do I really name that? What kind of name do I come up with? No, it shouldn't be the case. You should just be able to look at that grouping and say, oh, look, there's benzoic acid. So we'll go through and we'll name it accordingly. Folks, this is the common set of benzene molecules. And it is, again, one of the few times that I tell you to memorize anything. This should be learning, your learning processes, your learning mechanisms, your learning reactions. But this truly is memorization. It's the only way that we can get through the common names of the benzene-containing groups. All right. So, other things with nomenclature. Okay. Like you thought this wasn't enough, right? Well, as you can imagine, there's a couple of things that can happen here. One of the things that can happen is you have a long carbon chain. And that longer carbon chain has more carbons than the ring system does. So how do we handle it? You're going to look at this and you're going to say, well, Tracy, this is going to be an easy decision because I'm going to look at this and this is a benzene ring and I'm going to name this Benzyl, Benzyl, and I'm going to go, and not in here, you're not, because that's not the proper name. I know, chemistry, organic chemistry, it doesn't make sense often, and this is one of those times. So let me kind of explain why that is not the case. Here, we're going to have two different types of substituents. This is a benzene ring that's directly attached to the main chain. And down below, we have a benzene ring that is not directly attached to the main chain. There's a middle man, and this middle man is going to be a carbon. And then it's attached to the chain. So these two things are very common. They show up all the time in organic, and we have to be able to distinguish the difference between the two. If the benzene ring is directly attached to the chain, we call this the phenyl group, Phenyl. Now go back and remember some of those common names that I just did. One of those common names was this, right? And I told you that this was called phenol. Oh, well, now you know where the phen comes from, because that means that this is a benzene ring directly attached to something. What is it directly attached to? The all group. So there you go. That's a phenol. That's where that name originates from. So if the ring is directly attached, we call it the phenyl group. If the ring is on a middle carbon and then it's attached to the main chain, that is the one that we call benzyl, Benzyl. Okay, so let me write that a little bit better because this is important. This is important. Benzyl, benzyl. So there's two different common groups that hang off of these things on main chains, but we can also utilize these in terms of common names as well. So keep this in mind. Keep the difference in mind. We now know how to handle these if they are attached to a longer piece or a longer chain, but we can also use those names as part of the common nomenclature system as well. So here, let me give you an example. Let's say that we have a ring and we have CH2Cl. And I'm going to say, name it. Well, you're going to look at this and you're going to go, oh, well, I know what this is called. This is called chlorobenzene. And I'm going to go, no, it's not. It's not called chlorobenzene. And the reason is because chlorobenzene would be a benzene ring with chloro attached to it. And that's not what we have here. What we have here is a middle man. It's a middle carbon. And then it's attached to the benzene. Well, we now know how to name that grouping. If there is a benzene ring with a CH2 group on it, we are going to call this benzyl. right? That's just what we got finished talking about. And then what is with the benzyl group? That is a Cl for chloro. So benzyl chloride would be the common name for this structure, benzyl chloride. So phenyl benzyls we can use in common nomenclature system, but I could also call this chloromethylbenzene and really kind of delve into the world of IUPAC by doing that. But benzyl chloride would be an appropriate name. All right, so let me give you another example. Let's say that we have a benzene group here, and that is directly attached to an O, and that is on another ring. All right, so how would we name this? Well, back in Orgo 251, you learned that ROR was called an ether group, right? So this is an ether structure. Well, how do you name ethers? You name the thing over here and you name the thing over there. Well, this is a benzene ring that's directly attached to the O, and this is a benzene ring that's directly attached to the O. So we know that if we're talking about a benzene that's directly connected to something, then we're going to call this phenyl. And this is a diphenyl because there's two of them, one on the left and one on the right, and we add the word ether onto that. So diphenyl ether would be the appropriate name or common name for that ether. Okay, well, let's do another one. Let's say that we have this benzene ring that has this middle carbon that's then attached to the oxygen. So here we have an example of an ether group, ROR, but we need to name that piece over on the left. What we had seen up to this point were things like isopropyl and sec-butyls and butyls and pentyls and hexyls maybe. But we never really saw anything that had a ring system like this on it. Well, now's the time. So that benzene ring with the middle carbon that's attached to the oxygen, that is called the benzyl group. So there's two of these, one on the left and one on the right. So that would be dibenzyl, and then I add the word ether onto that. So dibenzyl ether would be the appropriate name for that structure. All right. I could, if I wanted to go through this and do this ring over here on the right, and 1, 2, 3, 4, right? Over here to the left. How would I name this ether? Well, I'll do the same thing, folks. There's no difference. So over here to the left, I've got a 1, 2, 3, 4. So this is a butyl group. And then on the right-hand side, this is a benzene directly attached. So I know that this is called the phenyl group. I put them in alphabetical order, just like always. So I'm going to call this butyl phenyl ether. And there you go. You've got it. So the general rule here is that these are okay. They're smaller molecules, right? We can incorporate benzyl and phenyl there. The benzene groups typically have 6 carbons on them, and we always look for the longest carbon chain. So there's going to be a moment in time where here's a 3-carbon chain, and then off of this, I could see a benzene ring. Okay, well, how do I name this? Do I include the 3 carbons as the main parent chain, or do I include the 6-membered ring as the main parent chain? Well, you always go back to the longest carbon chain. That's what this is always about. It's what it's always been about for IUPAC, meaning that benzene really takes priority. So I'm going to name this group on a benzene ring. So I'm going to call this propyl benzene. Okay, I'm going to name it as a benzene properly, and then the group attached onto this, I'm going to name that as a substituent. However, if I get a longer chain than 6, so here we go, 1, 2, 3, 4, 5, 6, 7, 8, and then let's say that we have a benzene ring here. Well, that main chain now is the parent chain. That has the most carbons to it. So here I'm going to default back to IUPAC, and this is going to be a 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. And then on carbon number 3, I'm going to have this group hanging off as a substituent. So how do I name that as a substituent? Well, if there was a Cl there, you would call it chloro. If there's a Br there, you would call it bromo. If there was maybe an ethyl group, you would call it an ethyl group, 2 carbons. So what do we call this benzene ring? We use those 2 words that we just learned. Use your words, use your vocabulary. So phenyl and benzyl would be the appropriate terms to use as a substituent name. So this benzene is directly attached to the main chain, so therefore that would be called phenyl, and we would call that phenyl octane. If there was a middle carbon, that would be called benzyl octane. All right, so here's a couple more examples. Here is a benzene ring with a 3-carbon chain up here at the very top. So this 3-carbon chain would normally be called propyl. However, this is in the middle, and that middle, that's a special term. So there's an isopropyl benzene. All right, then we move to 4 carbons up here at the top. So this 4-carbon system, this is not a middle carbon, but the second in line. This is a tertiary or secondary carbon, so therefore this is called a sec-butyl benzene. And then here we have 4 carbons in total, but that carbon is really tertiary, right? That benzene is attached to that carbon that has 3 others. So this is a tert-butyl benzene. And then here we see a 1, 2, 3, 4, 5, and then this 6-membered ring. So this one's kind of flippity-floppity. You can name it either way, however you want. The problem here is that with a 5-membered ring, we can't really call this sec-pentyl. And the reason is because that's also a secondary, but that sec-pentyl would be different than that sec-pentyl. So using a word like sec-pentyl does not work. So because of that, we really look at this pentane ring and we call it pentane for the parent chain. And then on carbon 2, we add the word phenyl. You can name it the other way. You're going to have to be more creative with the parentheses. It can be done, but folks, it's something that I tell you to stray away from whenever possible because it does overcomplicate things. All right, finally here, this last example, this is a 1, 2, 3, 4, 5. It is another pentane, so there we go. And then carbon number 3, I'm going to see that's where my benzene ring is attached. So 3-phenyl is going to be the nomenclature or name for that particular molecule. The other thing that I want to tell you about is this shorthanded notation that we always use in the benzene world. So for instance, notice all the way up to this point, we always used R to represent a random alkyl group. That's just the way that we represent it. We use R as a placeholder in a way to represent any random carbon chain that might want to be there. Well, we can do the same thing in the benzene world, and what we use is AR. Now, where do you think the AR comes from? Well, I hope that after this lecture and after the past few videos, you would know that AR means aromatic. And what that represents is basically a benzene group. All right, so for instance, AROH. Well, that AR represents the benzene, and there is an OH off of that. However, AROH can also be paired with other things as well. So we can see a benzene with an OH, and we might have a bromo on here too. Or we might have, I don't know, an ethyl group on here, CH2, CH3. That would also be an AROH group. So AR is just a random benzene ring. That is what that represents. Okay? All right, so that's where this lecture video is going to stop. Before, though, you click the close button, I want you to go back and I want you to take a look at this particular example problem. All right. So this example problem is going to say, draw the structure for the following: 2-phenylhexane, benzyl alcohol, 3-benzyl pentane, and bromomethylbenzene. So use what you learned in this video. Try to answer these questions without looking anything up. And then in the next video, we'll pick up from here. we'll answer these questions and we'll work through the nomenclature system to get a little bit more comfortable with what's going on. All right. So until then, I'll see you next time. Have your notes ready, have these questions answered, and then double check your answers with me before we move on in the next video.